I want to go over a few more optimization scenarios. Here's one that's got a cylinder. This is an open top cylinder, and we're told that the sides, basically, this part of the cylinder, that's made out of a different material than the bottom, and there is no top. So the bottom cost 15 cents per square unit, and the sides cost 5 cents. And they tell us that the volume is 24 pi. Now, volume of a cylinder is pi r squared h, and we want to minimize the cost. Now, the cost is kind of like the surface area, but these numbers, the cost goes, the cost of the sides and the bottom get factored in. So, 2 pi rh is what's called lateral surface area. That's the area of the sides. That needs to get multiplied by 0.05. And the bottom, the one and only bottom, is pi r squared h. And that has to get multiplied by 0.15. Oops, just realized we don't need the h. The height doesn't matter. The bottom is just a circle. Now, this top equation can be used to, if I divide both sides by pi r squared, I get h equals 24 pi over pi r squared. And the pi's cancel out. So h can be replaced with 24 over r squared. Substitute that in for this h, and we get c equals 2 pi r times h, which is 24 over r squared, times, don't forget about the 0.05, and this other thing is still pi r squared times 0.15. And we can cancel out one of these r's with one of these r's. And we end up with, if I simplify this equation, I'll write it on another page, this 24 times 4 times 2 is 48, and then 48 times 0.05 is 2.4. So we get this equation. Cost is 2.4 pi over r plus 0.15 pi r squared. Let's look at that. Yes. Now, this makes an unusual graph. It's actually, if I think of the r as the x and the cost as the y value, and I put that into the graphing calculator, we end up with some kind of unusual looking parabola thing. And which we're trying to minimize the cost. That point ends up becoming 2, 5.65. So this means that the radius of the cylinder is 2. The cost of the cylinder thing is 5.65. And if you were to plug that 2 into this equation, h equals 24 over r squared, it would be 6. So that tells us about that cylinder. Another question that's kind of unusual is this. When you go to a movie theater, and there's a screen that's the bottom of the screen is 8 feet above the ground, and the screen itself is 15 feet. And you want to know where you should sit. And of course the answer is sit behind someone who's shorter than you. But let's say the whole theater is empty and you could sit anywhere you want. Where's the ideal place to sit? Well, if you sit too far back, the screen looks kind of small. But if you sit too close, besides getting your neck hurts, the screen actually kind of looks small and distorted, because what we're trying to maximize is what's called the viewing angle, which I'll call theta. what, depending, you may think, well, it's the same no matter where I go, but when I get to the middle, you see this angle looks somewhat bigger here than if I go really far back. This angle looks smaller, and even if I get really close. So there's an optimal place to sit, and I'm going to show you how to calculate that. It's going to require making a graph on the graphing calculator. So here's the way this works. I call this distance x. I call that theta. No, don't call that theta. Call this theta. Now I need an expression for theta in terms of x, and I'm going to introduce two more names. This big angle here that has theta, I'm going to call this alpha, and this little one here, I'm going to call that theta. So we can say that theta, this angle here, is alpha, which is this entire angle, minus theta. Well, the thing about alpha is that if I just look at this triangle here with the alpha in it, and the 23 and the x, I can say that alpha, if I wanted to solve for alpha, it would be tan alpha equals 23 over x. So alpha is tan inverse 23 over x. And beta, if I look at the skinnier triangle, it has an x as its base, here's beta, and it has an 8 as its opposite side. So tan of beta is 8 over x, or beta is tan inverse of 8 over x. So now I have an expression that relates theta and x. And if on my graphing calculator I type in, y equals tan inverse of 23 over x minus tan inverse of 8 over x, I go into degree mode for that. You would get a really unusual looking picture, something like that. And we don't have a way to calculate this, but if we use the maximum feature on the calculator, we would find that point is about 13.6, comma 28.9. Which means when you're sitting 13.6 feet away, we have a maximum of a viewing angle of 28.9 degrees. Anywhere further back, it's a smaller angle of viewing, and any closer, it's a smaller angle of viewing and potentially hurting your neck. So you want to sit in the optimum spot unless there's somebody really tall sitting right in front of you, and then just go sit somewhere else. One more question, because there's more time to make on this video. Here I have another open top cylinder, but unlike the last one, this time I know that the amount of material is 3 pi square feet of material. In other words, surface area. Now this is an open top cylinder, so there's no top here. So the surface area is pi r squared, that's the bottom, plus 2 pi r h, and we're told that's 3 pi. That's the formula that only has two variables, the r and the h. We want to maximize the volume, so using this amount of material, how could I get the most volume possible? Well, V equals pi r squared h, which is pi r squared. I got to come over here and solve for h, and if I do that, I could divide everything by pi first. Then I could subtract the r squared from both sides and divide by r. So h is 3 minus r squared over over 2r. I also have that 2 there. So I'm going to replace this h with that. And if I just graph it, I'm going to make v my y and r my x. So I just do y equals pi times x squared over 3 minus x squared over 2x. We would end up with a little parabola looking thing as part of a much more complicated curve. And the coordinates would be 1 comma pi, which would mean that if you make the radius 1, and you could calculate the height also, it's not on the graph, but if I make the radius 1, then my height would be 3 minus 1, which is 2 over 2. The height would also be 1, and the volume of this cylinder would be actually pi. Okay, so what you've seen here is a couple of questions involving a cylinder and this unusual movie theater question. And that's optimization day 3.